The following is a system of linear equations, which we are going to solve using the substitution method. When you use the substitution method, generally if you have a variable by itself, in this case how we have a y with only a negative in front of it, that will be the easiest value to get alone. So, in order to do that in this problem, we're going to take the second equation and solve for y. So we'll start by subtracting 5x from each side of the equation, which gives us negative y equals 11 minus 5x. And then to get the y completely alone, we need to either divide by negative 1 or multiply each side of the equation by a negative. Both result in the exact same thing, but in this case I'll multiply, as it's generally easy to multiply by a negative compared to dividing by 1. So negative y becomes positive y, and that's equal to negative times positive 11 is negative 11, and negative times negative 5x is positive 5x. We're just distributing this negative. So y equals negative 11 plus 5x. We want to take that and plug it into the first equation. That's the substitution. So that gives us 2x plus 3 times y is negative 11 plus 5x, which we solve for over here. And that has to be equal to 18. So now we just have one equation involving x that's taking both equations into account because we plugged one into the other. So now we can solve for x. We'll start by distributing the 3. So we get 2x minus 33 plus 15x equals 18. And then 2x plus 15x gives us 17x minus 33 equals 18. And finally, we're going to add this 33 to each side to get the x alone. That gives us 17x equals 51. And finally, dividing each side by 17 gives us x equals 3. Once we get this value for x, we can plug it into the equation that we solved for when we got y alone. That gives us y equals negative 11 plus 5 times x we said is 3. So y equals negative 11 plus 15, or y equals 4. So the two values that solve both of the original equations are 3 for x and 4 for y, which we could do a quick check plugging them in to prove that. If you plug 3 in for x and 4 for y and solve each equation, you will get the 18 and the 11. So for our final answer, remember that whenever you're dealing with a system of linear equations, the answer is always the point of intersection. In this case, it's the point x comma y, which means it's the point 3 comma 4.